Now, previously we had talked about similar polygons and triangles in particular, and today we're going to look at parts of similar triangles and how they work. But let's review quickly. So here we have a similarity statement. These two triangles are similar, and we know 1, 2, 3, 1, 2, 3, A, B, C, D, E, F. So we know the sides are proportional and the angles are congruent. So that would set this up as AB over DE equals BC over EF equals AC over DF. Now we're going to apply this concept to other parts of the triangle beyond just the sides, because we do have segments in triangles that are on the inside of the triangle. And as it's going to turn out, if two triangles are similar, then the following corresponding parts are also proportional. So altitudes, which we have here, an altitude connects a side of the triangle to a vertex, and as long as the side and the vertex are corresponding in both, they are going to be proportional. So what we're going to have here is we're going to have BD, altitude number 1, and over FH, which is altitude number 2, and that's going to be the same as pick any corresponding side, AB over EF. That's going to be true. Then down here, we see this. So we know we're dealing with angle bisectors. And as it turns out, the angle bisectors are going to be proportional, once again, to any corresponding sides. In this case, let's pick a different one, PR and TV. The third one we get, well, what do we get here? Well, this is splitting. It goes from a vertex and splits the side in half. This one goes from a vertex and splits the side in half. So those are medians. Medians are also going to be proportional. So we get HJ. I can make a little better J. Over LN. And then we got to pick a side, a corresponding side that it's equal to. So GH over KL. So this is a powerful tool, lets us measure a lot more stuff in triangles given limited information. So let's look at some examples. Given similar triangles, solve for X. So that's what we're doing here. All right, so here it splits them off. So we got medians. We know medians are proportional. Our first median here is SW, which is X. Our second median is DF, which is 15. And then we just have to pick any side. So here we got 19.2 and 16. Well, I'm going to choose 16 because it doesn't include a decimal. And then I have to, and I've got 24 and 20. Well, just like any time we're matching up sides in a normal triangle, the littlest side goes with the littlest side, the biggest side goes with the biggest side, and the middle side goes with the middle side. So 16 is the smaller of the two. and 20 is the smaller of the two on this side. Then we cross multiply and solve for x. So really this is nothing new that we haven't done before. So we get 15 times 16, which is 240, 20x. We divide by 20, and we get 12 equals x. We're only solving for x, so we are done. Let's look at the next problem. GHI is similar to MLK, solve for x. Well, here we have altitudes. And first thing we want to do is line up our triangle. G is 1, H is 2, I is 3, M is 1, L is 2, K is 3. So we're going to go 10 over 8, because those are altitudes. Then we got X here is between 2 and 3. 14 is between 2 and 3, so we can match those two up. Cross multiply and solve. So 8x equals 140. Divide both sides by x, by 8, and we're going to end up with x equals 17.5. And we've done that one. So once again, nothing we haven't done before when we were dealing with scale factors, similarity statements, similar polygons, proportionality. Same process, doing the same process. Here, we see angles, so we know we're dealing with angle bisectors. So let's go ahead and write those down. We got A, B, C is 1, 2, 3, E, G, F is 1, 2, 3, so A is 1, B is 2, C is 3, E is 1, G is 2, F is 3. Let's see, where's our X here? Between 1 and 3. This is also 1 and 3. So let's see, ABC is on top, so we go 38 over X. We cross multiply, and we get 32x equals 912. We divide by 32, and we get 28.5 equals x. A couple more examples here. Now here, we have to remember that sometimes an altitude is outside the triangle. That still makes it an altitude of the triangle. They are still proportional. So we are going to get 12 over 15. PQ go together, UT go together. PQ is our X, and TU is our 42. We cross multiply. We have 15x over 504 divided by 15. And we're going to get an odd number, but that's okay. So x equals 33.6. One more example, and then we will stop there. All right, so KYC is similar to BLH. All right, so let's line these up. 1, 2, 3, 1, 2, 3. K is 1, Y is 2, C is 3, B is 1, L is 2, H is 3. Okay. Oh, look, we're cutting this side in half from the median, so that's a median from the vertex to the side, cutting in half. So we get 20 over 12. We get 2x plus 9 between 2 and 3. We need 2 and 3, so that's x plus 12. X minus 2, so 2x minus 9 over x minus 2. Same exact process that we've done before. We cross multiply. But both of these are divisible by 4, so I can actually reduce them down. So I'm going to do that, make the math a little easier. So we'll cross multiply and we get 3 times 2x minus 9 equals 5 times x minus 2. And if you don't recognize that you can reduce them beforehand, it doesn't matter. You will get the same answer. The only difference between this example and the previous ones are that we need to distribute. So we get 6x minus 27 equals 5x minus 10. Make sure to double check your signs. All right, so let's get the x's on the same side. Negative 10, make sure to bring that down. Then we get the x by itself. And we have x equals 17. And we are done. And we will do the second half of this lesson in another video.